Welcome back to our channel. Today we are discussing Chapter 9 Sequences and Series of Standard 11 Mathematics NCERT textbook. So we can go to the video. Today we can discuss sequences, the definition of a sequence and also some examples. Okay, we can see what is a sequence. A sequence is an ordered list of numbers or objects, or we can say a collection of objects or a set of numbers is said to be listed in a sequence if it is ordered in such a way that it has an identified first member, second member, third member, and so on. That is, a sequence should have an ordering so that we can identify first member, second member, third member, and so on. For example, we can say our alphabets starting from A and ending with Z. Say A, B, C, etc. Y, Z. Here it has an ordering. We can say first member is A, second member is B, etc. 20th member is Z. Another example, we can say the amount of money deposited in a bank over a number of years form a sequence. The amount of money deposited in a bank over a number of years. Say we can say from 2005 to 2022. The amount of money deposited in the bank. It will form a sequence. Or we can say the population of human beings at different times. We can say the same time period 2005 to 2022. The population of human beings will form a sequence. Another example, see, consider the successive quotients that we obtain in the division of 10 by 3 at different steps of division. The quotients obtained when 10 is divided by 3. See, 10 divided by 3 is 3, 9, here 1. The first quotient is 3. First step, the quotient is 3. See the next step, 10.3, 9. Here in the second step, the quotient is 3.3. Similarly, in the third step, the quotient will be 3.33. In the third step, 3.333 and so on. See, this forms a sequence. Here, the first member is 3, second member is 3.3, third member is 3.33 and so on. These numbers are called terms of the sequence, or we can say that the various numbers occurring in a sequence are called its terms. We can denote it by A1, A2, etc. Here, the first term is 3, second term is 3.3, third term is 3.33, or we can say A1 is equal to 3, A2 is equal to 3.3, A3 is equal to 3.33, etc. Here, this subscripts A1, 2, etc. It denotes the position of the term. Here, A1 is at the first position, A2 second position. Similarly, we can say nth term. At the nth position, we can define nth term and we can denote it by A, or this is called the general term of the sequence. General term. So, what is terms, nth term and general term? See, the various numbers occurring in a sequence are called its terms. We denote the terms of a sequence by A1, A2, A3, etc., An, etc. The nth term is the number at the nth position of the sequence and is denoted by An. The nth term is also called a general term of the sequence. Now, finite and infinite sequence. A sequence containing finite number of terms is called a finite sequence. Finite number of terms. See the example of our alphabet A, B, C, D, etc. Z. Here it has only finite number of terms, or we can say it has only 26 terms. It forms a finite sequence and a infinite sequence. A sequence is called infinite if it is not a finite sequence, or we can say that it never ends, infinitely many terms. For example, we discussed the example of the sequence of successive quotients in the division of 10 by 3. In each step, it forms a sequence 3, 3.3, 3.33, etc. It's an infinite sequence. That is, a sequence containing finite number of terms is called a finite sequence. Example, our alphabet. A sequence is called infinite if it is not a finite sequence. Example, 3, 3.3, etc. The quotients obtained by dividing 10 by 3 at a different stage. Now we can see more examples. Consider the sequence of even natural numbers. Even numbers or even natural numbers 2, 4, 6, 8, etc. Here we can say a1 is equal to 2 into 1, a2 is equal to 2 into 2, a3 is equal to 2 into 3, etc. an is equal to 2 into n or equal to 2n. Here we can define the sequence as an is equal to 2n. Nth term is 2n. When substituting n is equal to 1, we get first term, n is equal to 2, we get the second term, and so on. So we can define the sequence by an is equal to 2n. Similarly, we can define the sequence of odd natural numbers. 1, 3, 5, 7, 9, etc. Here we can define an is equal to 2 into n minus 1. Here when n is equal to 1, we get an is equal to 2 into 1, 2 minus 1, 1. When n is equal to 2, 2 into 2 minus 1, 4 minus 1 is 3. Now see another example. Consider the sequence 1, 1, 2, 3, 5, 8, etc. Here see, first term is 1, second term is 1, and the third term is 1 plus 1, adding first and second term, and the fourth term is 3, adding second and third term, 1 plus 2, and so on. So we can define a1 is equal to a2 is equal to 1, a3 is equal to a1 plus a2, etc. an is equal to an minus 1 plus an minus 2, sum of preceding terms, for n greater than 2. When n equal to 1 and n equal to 2, we get a1 is equal to a2 is equal to 1. When n greater than 2, we can substitute this equation. When n equal to 3, we can say a3 is equal to 3 minus 1 is 2 and 3 minus 2 is 1. When n equal to 2, it will become 0. So we cannot define a general equation. So we are taking n greater than 2. See another example for a sequence of primes. Say 2, 3, 5, 7, 11, etc. Here we cannot define a general term or no formula for nth prime or nth term. We cannot define a formula. In the above examples, we define a particular formula for obtaining the general term, or to get the terms of the sequence, we define a formula. But here we do not have a formula, but it forms a sequence. Or we can say that we should not expect always a formula, but there should be a theoretical rule for finding the terms. Here this is a primes, first prime, second prime. There should be an ordering, third prime, fourth prime, fifth prime, etc. Or we can say another definition for sequence. Sequences can be regarded as a function whose domain is the set of natural numbers or its subset. We can regard sequence as a function. From set of natural numbers or its subset. That is, a set of natural numbers is 1, 2, 3, etc. We can define a rule. We usually denote functions in the form f of x, g of x, like that. So here the domain is natural number. So we can define, instead of an, a of n, the functional notation a of n. It's a function from natural numbers. So its terms can be defined as a of 1, a of 2, a of 3, etc. We have seen what is a sequence. We can discuss more examples later. Before that, we can see what is a series. Let A1, A2, A3, etc. An be a given sequence. Then the expression A1 plus A2 plus A3 plus etc. plus An plus etc. is called the series associated with the given sequence. We can say the series is finite or infinite according to the sequence. If the sequence is finite, then the series associated with it should be finite. And if the sequence is infinite, then the series should be infinite. Here, see, the summation is involved. So, we are denoting the series by the sigma notation. So, consider the series A1 plus A2 plus etc. plus A. We can denote this series by sigma AK. K varies from 1 to n. When k equal to 1, we get A1. K equal to 2, we get A2. Sigma summation. A1 plus A2 plus etc. plus an up to n. So we can write the definition as, let A1, A2, A3, etc. An be a given sequence. Then the expression A1 plus A2 plus A3 plus etc. plus An plus etc. is called the series associated with the given sequence. And we denote it by the sigma notation. Now we can discuss more examples. See the example. First one, write the first three terms in each of the following sequences defined by the following. First one, an is equal to 2n plus 1. Second one, an is equal to n minus 3 by 4. Here we have to find the first three terms. Substitute n is equal to 1, 2, 3. Then we get a1 is equal to 2 into 1 plus 5, which is equal to 2 plus 5 is 7. N equal to 2, A2 is equal to 2 into 2 plus 5, which is 4 plus 5 is 9. When N is equal to 3, A3 we get 2 into 3 plus 5, Z, which is equal to 6 plus 5, 11. Similarly, second one, substitute N is equal to 1, 2, 3. When N is equal to 1, we get A1 is equal to 1 minus 3 by 4, which is equal to minus 2 by 4 or minus 1 by 2. A2 is equal to n equal to 2. 2 minus 3 by 4, which is equal to minus 1 by 4. A3 is equal to 3 minus 3, 0 by 4, which is 0. Or 3 minus 3 by 4, which is equal to 0. Here we can say, here the first three terms are 7, 9, 11. You can write it in order, 7, 9, 11, first three terms. Or here the required terms are minus 1 by 2, minus 1 by 4, 0. See the next example. What is the 20th term of the sequence defined by an is equal to n minus 1 into 2 minus n into 3 plus n? Here n is defined by n is equal to n minus 1 into 2 minus n into 3 plus n. We have to find the 20th term. So put n is equal to 20. Then we get 20th term, A20 is equal to 20 minus 1 into 2 minus 20 into 3 plus 20, which is equal to 19 into minus 18 into 23. We will get this answer as 7866. Next example. Let the sequence A and B defined as follows. A1 is equal to 1 and An is equal to An minus 1 plus 2 for n greater than or equal to 2. Find first 5 terms and write corresponding series. So here the sequence is defined by A1 is equal to 1, An is equal to An minus 1 plus 2 for n greater than or equal to 2. So first term A1 is equal to 1. We have to find first 5 terms. Now second term A2 equal to, substitute n is equal to 2. We get A1 plus 2, which is equal to 1 plus 2, which is 3. A3 is equal to A3 minus 1, which is A2 plus 2. A2 plus 2. A2 is 3, A2 plus 2 is 3 plus 2, 5. A4 is equal to A4 minus 1, A3 plus 2, which is equal to, A3 is 5, 5 plus 2 is 7. And A5 is equal to A5 minus 1, A4 plus 2, which is equal to 7 plus 2, 9. So the first 5 terms of the sequence is 1, 3, 5, 7, 9. And second part of the question is we have to write the corresponding series. Here the sequence is 1, 3, 5, 7, 9. Therefore, the corresponding series is 1 plus 3 plus 5 plus 7 plus 9. If we have given a sequence A1, A2, etc. An, then the corresponding series is A1 plus A2 plus A3 plus etc. plus An. So this is the series. Hope you understand what is a sequence and what is a series. We can discuss more exercises in the next video. See you in the next video. Thank you.